Hi students, welcome to physics classes. Today we'll discuss how does a battery work. How does a battery work? Now this is a battery. It consists of two terminals are called electrodes. Battery consists of two terminals are called electrodes, and there will be a chemical is known as electrolyte. Chemical present in that is known as electrolyte. That chemical contains positive ions and as well as negative ions. Chemical consists of positive ions as well as negative ions. Now, chemical exerts a force on these ions to move in opposite direction to each other. For example, positive ion is moving like this, negative ion will move in opposite direction. These all positive ions will move towards a plate and accumulate on the plate, and these negative ions will move towards one plate and accumulate on the plate. As a result, this positive becomes positive terminal and this becomes negative terminal. Now while the ions are moving, chemical force acts on it to move in one particular direction. When the ions are in motion, there will be electric force acts on them in opposite to the direction of chemical force. When a positive ion is moving in this direction with the help of chemical force, on it electric force is acts in opposite direction, and when the negative ion is moving in this direction with the help of chemical force, on it electric force is acting in opposite direction. Now when they are in motion, chemical force acts on it and electric force. Two forces are acting on one ion. Results, the ion moves in the direction in which magnitude of force is more. If chemical force is more, it will move towards chemical force. If electric force is more, it will move towards electric force. When the plates are not sufficiently charged, electrodes are not sufficiently charged, chemical force is greater than electric force. So these ions will move towards their respective plates. Whenever they are getting sufficiently charged, whenever these plates are sufficiently charged, chemical force is equal to electric force. Chemical force is equal to electric force. So that remaining balanced force, whenever two forces are acting on an ion and both are equal, those we can say balanced forces. So it won't move any direction because two forces are acting in opposite direction and their magnitudes are equal. So these ions will not move, and even these plates are sufficiently charged. So no need to accumulate charges on the plate. This is how battery will be. Now we'll see working of a battery. Working of a battery. Whenever a battery let us take positive terminal, negative terminal connected in the circuit. Whenever a battery connected in the circuit, there will be a electric field set up throughout the conductor. That electric field makes the electrons to move in a specified direction in the conductor that we seen in the previous topics. Now whenever electric field set up throughout the conductor, what is the direction of electric field? From positive terminal to the negative terminal in the conductor. The direction of electric field is from positive terminal to the negative terminal in the conductor. You can observe this direction from here onwards like this. This is the positive terminal. In the conductor I am saying like this it will be. Now that electric field makes the electrons to move in specified direction by providing necessary force. Now how it will be working? Now the electron conductor contains large number of free electrons. Conductor contains large number of free electrons. The electron near the positive terminal is attracted by the positive terminal. Because it is a positive terminal, this is electron negative. So it will be attracted. Now we already seen here this battery already sufficiently charged. So it is already having sufficient amount of charge. Plus. Now whenever a negative electron entered, then as a result amount of charge will be decreased here. Whenever amount of charge is decreased, means not sufficiently charged. Whenever electron entered, amount of charge will be decreased. Then we'll come to this situation. Chemical force becomes greater than electric force. Now this is the negative electron. Now on this chemical force acts. What chemical force will do on the negative electron? It will move towards negative plate. Chemical force acts. In this situation, chemical force is greater than electric force. That chemical force makes the negative ions towards negative terminal. So that negative terminal will come to the negative plate. But here negative plate already sufficiently charged. It not requires any extra negative ions. So this negative plate will pushes one electron into the conductor because strong repulsion between electron and a negative plate. Here electron is attracted by the positive plate. Amount of charge will be reduced because these all are plus 1 minus came. That negative on the negative electron, chemical force acts on it and makes it to move towards negative terminal, and already negative terminal is sufficiently charged and it will pushes one electron into the conductor. Here electrons in the conductor remains constant. One electron entered here, one electron came out of here. So it contains electrons remain same as previous. Now Again here charges are accumulated, balanced charges sufficiently charged, so again chemical force becomes electric force. Chemical force is equal to electric force. Like this continuously electrons will move in the conductor and through the battery. Like this it will move, so whenever electrons are moving in this, current is flowing, bulb will glow. Okay, this is the working of a battery. Working of a battery. Now we'll discuss Ohm's law, which is very important question in the examination point of view. Lab activity, most of the times they are asking in the board exams. Aim to show the ratio of Vi is constant. Ratio of potential difference to electric current is constant. Now for that we need some materials. 6 volts battery eliminator, ammeter, voltmeter, copper wires, manganese coil, manganese wire in the shape of coil, rheostat are required to verify Ohm's law first. Next we will replace manganese wire with LED, light emitting diode. First we will connect the circuit like this. Arrange the circuit like this. Voltmeter, which is used to measure potential difference at the end of the manganese wire. Ammeter, which is used to measure electric current in the circuit. Battery eliminator and rheostat. Now first we should arrange circuit like this, and knobs of the battery eliminator adjusted to 4.5 volts, and rheostat potential difference its range from 0 volts to 4.5 volts. First we will adjust to 1 volt. 1 volt rheostat is adjusted to potential difference 1 volt between the ends of the manganese wire. When potential difference is 1 volt, measure the current by using ammeter and note down in the table. Now here in examination point of view, we should draw the empty table. We need not to write values, because in the exam we are writing the procedure, not experiment. Now we'll mention there, adjust the potential difference in the rheostat 1 volt and measure the current in the ammeter and note down in the table. Next repeat the same procedure for different values of potential difference. PD means potential difference in the rheostat. It will be 0 to 4.5 only maximum. 0 to 4.5. Between them already 1 taken. Another 3 to 4 values we can take. 1.5, 2, 3, 4, 4.5 like that. And corresponding current in the ammeter we will measure. Electric current in the ammeter we can measure, that we will write in the table. After writing for every instant for potential difference we found the current in the ammeter that is flowing through the circuit, V by I, every instance V by I is equal to constant. We observe that for every instance of potential difference and electric current, V by I, V divided by I is constant. So we can write V is directly proportional to I. Potential difference is directly proportional to electric current. Now if you draw the graph between these values, V by taking on x-axis and I on y-axis, if you draw the graph will be linear. Graph will be linear when we take an magnetite wire. This is the result. Now if you replace this magnetite wire with LED, this is the LED. It will have one longer terminal, another one shorter terminal. Longer terminal indicates positive, shorter terminal indicates negative. That we will connect in the circuit. Instead of magnetite wire, we will connect the LED in the circuit. The same circuit, remaining everything is same. And we will connect LED in the place of magnetite wire. Then again same procedure by adjusting battery eliminator to 4.5 and potential difference between 0 to 4.5, different values of potential difference. We'll find the I and we'll measure V by I, and we found it is not constant. It is not constant. Whenever we use LED, it is not constant. So Ohm's law is applicable to some of the materials and it is not applicable to some other materials. That we will discuss. Now V is directly proportional to I. So to remove this proportionality symbol, we will take one constant, that is R. R is resistance. I is electric current, V is potential difference. R is resistance. Its units ohm. SI unit of resistance is ohm. This is the symbol, ohm symbol. Now we seen when we connect LED, we didn't get VI equal to constant. So from that we can say Ohm's law is having some limitations. Ohm's law has some limitations. Means Ohm's law is applicable to some of the materials and it is not applicable to some other materials. Now if you take gaseous conductors or semiconductors, Ohm's law is not applicable. Ohm's law is not applicable. Semiconductors in the sense we can take germanium and silicon. Semiconductors, germanium, silicon. Means Ohm's law is applicable to some materials. Those materials are known as ohmic conductors or ohmic materials. Which obeys the Ohm's law. Which obeys the Ohm's law are known as ohmic materials. Ohmic materials. which do not obey the Ohm's law are called non-ohmic materials. Ohmic materials and non-ohmic materials. Now resistance. Here we seen V is directly proportional to I, V equal to IR, R is the proportionality constant, is known as resistance. SI unit is ohm. Now resistance. What does it mean by resistance? Resistance means which opposes the flow of electric current. Which opposes the flow of electric current is known as resistance. Is known as resistance. Which opposes the flow of electric current is known as resistance. Resistance is offered by a device called resistor. This is the symbol of resistor. This is the symbol of resistor. Now we'll discuss electric shock. This question also most of the times asking in the board exams. Electric shock. Now human body is a conductor of electricity. Whenever we touch electric wires, body in electric current will be entered into our body. Then we will get shock. Now we will discuss how does this takes place. Now let us assume human body is a resistor. Even if it is a conductor, our body can oppose electric current. We can resist the flow of electric current. For example, the resistance of our body is 100 ohms to 5 lakhs ohms. 100 ohms to 5 lakhs ohms. 100 ohms means our body is wet with salt water, sweat. 5 lakh ohms means dry. Skin is very dry. Then you can offer more resistance. Whenever we touch a wire of 24 volts, if our body resistance in that situation is 1 lakh ohms, now what is the current entered into our body? V equal to IR, I equal to V by R, then V equal to 24 volts, R equal to 1 lakh ohms. Now 0.24 amperes current will be entered into our body. 0.00024 amperes current will be entered into our body. Whenever this much current is entered into our body, we won't feel anything. We won't feel anything. We can't feel. Next, suppose if this wire is 240 volts, potential difference is 240 volts. We'll take the same resistance, 1 lakh ohms. Then current is entered into our body 0.0024 amperes. If this much current is entered into our body, if this much current is entered into our body, it disturbs the functioning of our body. It disturbs the functioning of our body. Now, whenever this much current is entered into our body, it disturbs the functioning of our body. That disturbance inside of our body is felt as electric shock. It is a disturbance. It is a disturbance inside the body that is known as electric shock. If this current is flowing into our body, it damages the tissues. It damages the tissues of our body. Whenever current is entered into our body, it chooses a path which has least resistance or low resistance. Now damages the tissues. Now whenever tissues are damaged, resistance of our body decreases. Resistance of our body decreases. As we know, I equal to V by R. As we touch the same wire, 240 volts, we didn't change the wire in the middle. Whenever we touch the wire, we got shock and we are continuing. We hold that wire only. We didn't change the wire. Now if it is continuous, as current is directly, electric current is equal to V by R, V is a constant. Whenever it is constant means only this situation. Don't think that V is always constant. In this situation, V equal to 240 volts. We are touching the same wire. Again and again 240 volts potential difference is there. Okay, but as V is constant, we can say I is inversely proportional to R. Electric current is inversely proportional to resistance. Electric current is inversely proportional to resistance. Now electric current is inversely proportional to resistance. Now here we see when the tissues are damaged, resistance of our body decreases. If resistance of our body decreases, flow of current into our body will be increases. Flow of current and the body will be increases. Remember that same wire, 240 volts, resistance is decreased, then current is increasing. So whenever current is increased, it damages the further tissues. Whenever further tissues are damaged, still our body resistance will be decreased. So flow of current will be increases. Like this, it damages the all parts of our body. Whenever the current reaches 0.07 amperes, whenever the current reaches 0.07 amperes, it affects the functioning of heart. It affects the functioning of heart. If this much current continues to pass through the heart for more than 1 second, the person could be fatal. It is not giving much time. It is giving only 1 second. More than 1 second, person would be fatal. If this current flows continuously, the person is being killed. the person is being killed. Now we'll see how much current will affect what organs and what effect. Now if the current is 0.001 amperes, then we can feel whenever we touch the wire, if this much current is entered into our body, we can feel we got shock, electric shock. If it is 0.005 amperes, is painful. It is painful. We'll get pain. If current is 0.010 amperes, causes involuntary muscles contraction. We have two types of muscles: voluntary muscles, involuntary muscles. Involuntary muscles contraction. It causes involuntary muscle contraction. If this current reaches to 0.015 amperes, loss of muscle control. Loss of muscle control. Even we want to leave the wire, we can't. Our muscle control is not in our hand, our situation, our control. It won't be controlled by us. Okay. Now if this current reaches 0.07 amperes, if this current is passing through the heart, it is a serious damage, probably fatal, and being killed. This is about electric shock. In the electric shock, we seen potential difference, electric current, and resistance. So we can say electric shock is a combined effect of potential difference, electric current, and resistance of human body. Okay, thank you for watching. Please subscribe.